In this next video, for sections 5.3 and 4, we're going to be continuing our discussion of some of the different things that we can do with polynomials. In the last section, in 5.2, we talked about adding and subtracting polynomials. Well, in this section, we're going to move on to the next of the operations, and we're going to talk about how to multiply polynomials. So let's just do a little bit of recap from a previous section. So recall that from a previous section, 5.1/5, that when multiplying exponential expressions with the same base, you must add the exponents and keep the base. So that is, remember, the product rule, which was our very first exponent rule that we had in that section. So let's look at an example just to kind of review that product rule before we look at the rest of this section. So we'll just do an example here. Let's do 2x to the 7th times negative 3x to the 5th times 4x to the 8th. Okay, so to use the product rule, we have to multiply numbers together. So we can multiply 2 times negative 3 times 4. So that's going to give me 2 times 3 is negative 6, times 4 is negative 24. And then we can add the exponents because they all have a base of x. We can add together those exponents and keep the base. So the base will remain as x, and then we'll have 7 plus 5 plus 8, which is 20. So then this will become negative 24x to the 20th. Okay. So again, that is the product rule that says we can add our exponents when the bases are the same. So in this example here, we were multiplying polynomials of one term each. So in other words, we were multiplying together 3 monomials. All right, so multiplying 3 monomials together, we would go through this process. But in this section, we're going to look at how not just to multiply monomials by other monomials, but we're going to talk about monomials times binomials times trinomials and so on. So we're going to look at a little more than just multiplying things like this. So to multiply 2 or more polynomials, just kind of in general here, multiply every term in the first polynomial by every term in the second polynomial, and what will happen is you'll get a new polynomial that you will need to simplify by combining like terms. So just like we did in the last section, we talked about combining like terms to simplify. We're going to do the same thing in this section. So just one example of something that we'll see, something like negative 2a times the quantity a plus 4. All right, so to do this, well, in the past, we would say I have parentheses. So I can use the distributive property, and, well, that exact same thing applies here too. I can distribute this negative 2a, multiply this monomial, it's a polynomial, times every term in this binomial. So we're going to take negative 2a times a, and then we're also going to take negative 2a times positive 4. So then now it's just using exponent rules to simplify. Negative 2a times a will give me negative 2a squared, and then negative 2a times 4, that will give me negative 8a. And so these are not like terms, so I can't combine, so that's my final answer. So multiplication of polynomials is really just another way of saying that we're going to use the distributive property. Because that's really all we did. We just distributed the negative 2a on the outside of the parentheses and distributed to every term inside the parentheses. Okay, let's look at another example that also uses the same property. Let's say we have negative 4a squared outside, and then we have 5a squared minus 4a plus 7. Okay, so this time we're taking one term on the outside, multiplying it by every term on the inside. So again, we are using the distributive property. So we're going to take negative 4a times 5a squared we'll take negative 4a times negative 4a, and finally negative 4a times positive 7. And now we just need to simplify each of these products. So we have negative 20a to the third, we'll have positive 16a squared, and then negative 4a times 7 will give me negative 28a. And again, these are not like terms, so I can't simplify any further. So that's my final answer. Now, in most of these, I'm not going to show this step, but I did want to show it for these first couple of problems just to show you just what exactly is happening when we distribute that term. Okay, so let's look at another one. Let's keep going. Let's multiply this time a plus 4 times a minus 9. Now this one is a little bit different because here we have a binomial times another binomial. So the distributive property, we're not going to be able to use it exactly the same way that we did in these first two, but we can use it in a very similar way. Remember, the rule says to multiply two or more polynomials, multiply every term in the first polynomial by every term in the second polynomial. And it just so happens that this first polynomial has two terms, so we're going to multiply both terms by every term in the other one. So we're going to multiply every term in a plus 4 by every term in a minus 9. So what we're really going to do then is we're going to have a times a, and then we'll have to take the a times the negative 9. So then that'll give me a times negative 9. So we've distributed the a to both terms in the second polynomial. Now we need to distribute the 4 to both terms in the second polynomial. So we'll have 4 times a, and then 4 will distribute to negative 9. And now we just need to simplify. So I have a squared, and then I have negative 9a. Here I'll have positive 4a, and then 4 times negative 9, that will give me negative 36. And so these, I do have some like terms. I have negative 9a and positive 4a. I can certainly combine those. So I'll have a squared, and then this will give me minus 5a minus 36. Okay, now that's simplified, and so now we can say that one is done. All right, let's look at another example of this binomial times binomial problem. Let's do 4x minus 5 as our first binomial times 2x minus 9. All right, now in this one, I'm not going to go through this step, but I will go through the process of the multiplication. So we are going to take 4x times every term in the other second polynomial. So 4x times 2x, and then we'll do 4x times negative 9. So if we do 4x times 2x, that's going to give me 8x squared. If I do 4x times negative 9, that's going to give me negative 36x. And then if I multiply the next term by every term, the negative 5 by every term in the parentheses, then I'll take negative 5 times 2, which will give me negative 10x. Now notice that negative 10x and 36x, they would be like terms. So what I'm going to do in these is I'm actually going to line up my like terms. It just makes it easier to know what can simplify when we get to the end, because sometimes these problems can have a lot of terms. And so being able to very easily identify what you can simplify just makes the problems easier to work with. So that's why I'm going to line up the terms whenever I have like terms. F is negative 5 times negative 9, that equals positive 45. So now I'm just going to add down the columns. So 45, here I have negative 46x, and then 8x squared. I'm just going to bring that down because it doesn't have anything to add with. So I'll have 8x squared minus 46x plus 45. Okay, and that's all we really have for that example. Okay, let's do one more of this binomial times binomial. Let's look at the problem of 3x squared plus 1 times 2x squared minus 5. Let's take a look at this one. So we're going to do the same thing. Binomial times binomial. Every term in A, or every term in the first polynomial, times every term in the second polynomial. So 3x squared times 2x squared. So 3 times 2 gives me 6. X squared times x squared, that gives me x to the 4th, because we're going to add these exponents here. And then I'll take 3x squared times negative 5. That will give me negative 15x squared. And then so then I've distributed the 3x squared. Now I need to distribute the 1. So here I'll have 1 times 2x squared. So that's 2x squared. And again, like terms, so I'm going to line them up. And then 1 times negative 5, that's going to be negative 5. So again, I can now simplify very easily, because I can see my like terms. I have the negative 15x squared plus 2x squared. I can combine those very easily. So that will give me negative 13x squared. And then we'll have to bring down the minus 5 and bring down the 6x to the 4th. So there's our final answer of 6x to the 4th minus 13x squared minus 5. So in all of these, it is simply multiplying every term in your first polynomial times every term in the second polynomial, and then combining your like terms. Okay, let's turn the page, and let's look at some more examples of this. All right, so a lot of the last examples that we just looked at were all of the case where we were multiplying two binomials together, meaning they each had two terms. And so to help us remember this, the order of how to multiply the terms, we can use the word FOIL, so F-O-I-L. So it's not really a word in this case, but it's more of an acronym. We use each letter in the word FOIL to represent a part of the problem. So for first, the F means first, the O is outer, the I stands for inner, and then the L stands for last. So you'll see that all of the letters there, they spell out the word FOIL. So let's use a couple of examples, kind of like what we did earlier, that show how this FOIL method really works. So we'll just do one example here. We'll do x plus 5 times x plus 3. Okay, so first, meaning first terms, all right, we're going to multiply the first terms in each polynomial. So the first terms are x times x. So that's my f. So we have x times x. And then we do the outer. So we're going to look at the outermost terms. In this case, the outermost terms are x and positive 3. So x and positive 3. So that's my O. And so we have x times 3. And then the I is the innermost. So the innermost terms are going to be 5 and x. So I have I gives me 5 times x. And then we have the last terms in each of these, which is 5 times 3. So we have the L. Okay, so we've multiplied. So notice it looks a lot like what we had earlier, multiplying every term in the first polynomial by every term in the second polynomial. In this case, we're just putting a kind of a process with it, just a way to remember what the steps are. So it's all very much the same from here on out. X times x is x squared, x times 3 is 3x, x times 5 is 5x, and 5 times 3 is 15. So we can now multiply all of these, we've already multiplied them, but we can combine them. We can simplify. So 3x and 5x, those simplify to give me x squared plus 8x plus 15. And so from there, I can call that completed. All right. So again, FOIL is just a way to remember what the steps are to multiply two binomials. All right, let's do another one just to make sure we really have a good handle on this. Let's do 9x plus 8. No, let's do 9x squared plus 8 times 3x minus 1. All right, so this one, we can multiply the first terms together. So 9x squared times 3x, that will give me 27x cubed. And then I can multiply 9x squared times negative 1. So that will give me negative 9x. Then I multiply the 8x times 3x. That will give me 24x. And then I can multiply the last terms. 8 times negative 1 will give me negative 8. So I've got my first, my outer, my inner, and my last. But notice in this one, there are no like terms. Everything, there's nothing that has the same. I can't simplify it anymore because I can't combine anything. So this 27x cubed minus 9x squared plus 24x minus 8, that is your final answer. And that one just can't simplify it. So sometimes you can simplify, sometimes you can't. It just depends on whether you have like terms or not. Okay. All right. Let's go ahead and let's take a look at the bottom of this page. All right, we can also use FOIL to multiply a binomial by itself. All right, so multiplying one binomial times another binomial, well, it also works if it's the same binomial. And so it's going to look something like this. Just a quick example here would be 5x plus 6 in parentheses like that. But what we do to show, rather than writing it out twice, because it's just multiplying it by itself, we put an exponent outside those parentheses. So take note of that exponent right there. That's a very important part of this problem, is that exponent. So we have that exponent there, and it just means that we're doing, the binomial 5x plus 6 times the binomial 5x plus 6. All right, so let's look at some examples of how we use that notation to work math problems. All right, so example 1 here, we'll do x plus 1, and then we'll do the quantity squared. So x plus 1 quantity squared. So what this means is that we have x plus 1 times itself. All right, just like if we have x squared, it's x times x. Well, in this case, we have the quantity x plus 1 times the quantity x plus 1. So it's the binomial times itself. So it's still the binomial times the binomial case. We can still use FOIL. All right, so that's exactly what we're going to do here. We can use FOIL. All right, so FOIL says first terms, and then outer terms, inner terms, and last terms. So my first terms will give me x times x, that's x squared. My outer terms give me x times 1, that's just x. Inner terms give me 1 times x, that's still x again. And then 1 times 1 is 1. So we can add these up. We can have x plus x is 2x. So x squared plus 2x plus 1. And that's all we have there. Okay, so x squared plus 2x plus 1. Just another example. Let's look at 8x plus 3 and the quantity squared. So again, it's the same thing. It's saying that we have 8x plus 3 times itself 8x plus 3. Okay, so again, we're going to use FOIL. So we'll do first outer, inner, last. So we have 8x times 8x. That gives me 64, and then x times x gives me x squared. So I have 64x squared. If I multiply the outer terms, I have 8x times 3. That equals 24x. If I multiply the inner terms, I get 3 times 8x. That also gives me 24x. And then out here, I have 3 times 3. That will give me 9 from those last terms. So from there, I can combine like terms. So I have the 24x's. Those are the same. So that will give me 48x. And then just bring down the plus 9 and the 64x squared. And there we have it. And that one is completely finished. Okay. All right. So that is a couple of examples of where we take a binomial and we multiply it by itself. Okay. Something I do want to point out before we look at another type of problem, I want to talk about that exponent, right? It's important to remember that we don't distribute the exponent, all right? Because this, something like this, it kind of looks like what we had, when we had in 5.1, when we'd have something like this, and I'd say, well, you can distribute the exponent, all right? But notice in all of these, we have a plus, or we could also have a minus. We have, we don't have a plus or a minus here in this case. So this is the power to power rule, all right? But when you have a plus or a minus, we don't distribute. So doing this, doing that, where we distribute an exponent here, that is wrong. Do not do this. Don't do this. Okay, so don't distribute exponents when you have addition or subtraction inside parentheses like this. Multiply them out, one binomial times the other. Okay, so you cannot do that when terms are being added. You can only do it when they're being multiplied. Okay, so I just wanted to talk about that. Don't fall into that trap of distributing the exponent because what happens is you'll get the wrong answer. So don't do that. Only distribute when there's multiplication, not when there's addition and subtraction. All right. So that's enough on that. I'm sure I'll talk about that more in class. But let's go ahead and let's take a look now at the next type of problem that I want to look at, and that is the multiplication of the sum and difference of two terms. All right. So an example of something like that might be 3x plus 2 times 3x minus 2. All right, so remember, so in one polynomial, we're taking 3x plus 2 and we're adding them. So this would be the sum. In this one, we're taking 3x minus 2, we're subtracting them. So that would be the difference. And so what we're doing is we're multiplying the sum of two terms times the difference of two terms, where 3x and 2 are the terms. Right, so these are my terms. All right, so we're taking the sum and the difference. So let's see what happens here with this one. So first example we'll do is x plus 7 times x minus 7. Okay, so my two terms are x and 7. We're going to multiply the sum of the two terms by the difference of the two terms. So we'll do FOIL. So first, outer, inner, last, because these are just binomials. So we can use x squared from the first terms. The outer terms, that will give me minus 7x. The inner terms give me positive 7x, so I'm going to write that underneath just so that everything is lined up. And then 7 times negative 7, that's going to give me negative 49. Okay, so now we just need to combine our like terms. So negative 7x plus 7x, well, in this case, the terms are actually going to cancel out because they're opposites. Negative 7 plus 7 is just 0. So those are opposites. They cancel out. All you're left with is x squared and minus 49. So whenever you multiply the sum or difference like that, you're going to get those middle terms canceling out. Okay, another example of this. Let's look at 8x plus 3z times 8x minus 3z. So we're going to use the same process, the FOIL. First, outer, inner, and last. So I have 8x times 8x, that is 64x squared. If I multiply 8x times negative 3z, that's going to give me negative 24x z, right? So we're just multiplying the x and the z together. If I multiply the inner terms, that's going to give me a positive 24xz. And then my last terms, I'll get 3z times negative 3z will give me negative 9, and then the z's will multiply to give me negative 9z squared. So again, if we look at our like terms, the 24xz and the negative 24xz, those are opposites. They're going to cancel out. So I have to bring down my 64x squared, and then I don't have my xz terms anymore because they canceled out. And then I bring down the negative 9z squared from right there, and that's all I have. I can't combine them, again, because they are not like terms, so that is going to be my final answer. Okay. All right. So those are just a few examples of talking about multiplying a binomial times another binomial. All right. So we've spent a lot of time talking about multiplying binomials together. Like I said, polynomials that have different numbers of terms. It doesn't always have to be binomial times binomial. So we can multiply when they have a different number of terms. For example, I can multiply a binomial with 2 terms with a trinomial that has 3 terms. All right, so we're just going to do an example of this. So number 1, we'll just call it number 1. Let's do a plus 2 times 3a squared minus a plus 2. Okay, so, but it's still the same process. We have a polynomial, we'll call this one p, we'll call that one q. All right, we have a binomial, we can multiply by a trinomial, we can multiply every term in p by every term in q. So we'll multiply the a and multiply the to every term, multiply the 2 also to every term. So notice this one has a little bit more going on in it than FOIL. All right, we can't really use the word FOIL to multiply it out. FOIL doesn't work here. All right, FOIL can only be used on binomial times another binomial. So in this case, because we have a trinomial as one of our polynomials, the FOIL, the word itself doesn't really work, but the same idea of FOIL does. Because really what we're doing is we're just distributing every term in P to every term in Q. So I'm going to take my a times 3a squared, so that'll give me 3a cubed. I'm going to take a times negative a, that's going to give me negative a squared. And then I have a times 2, that's going to give me 2a. Okay, so we've distributed the a to every term in the second polynomial. Now we're going to distribute the positive 2. So I'm going to take 2 times 3a squared, that equals 6a squared. And since it's a like term with the negative a squared, I'm going to line it up just like that. Next, I'll take the 2 to the negative a. That will give me negative 2a. And then finally the 2 multiplied by the positive 2. So 2 times 2, that equals 4. All right, so then we've multiplied everything. Now we need to combine the like terms. So this time I have a squareds that are like terms, and I also have a terms that are like terms. So the 3a cubed and the 4, I'm going to bring those down. So 3a cubed and the positive 4. But negative a squared plus 6a squared, those will combine to give me 5a squared. And then I have my 2a minus 2a. Well, again, look at what we have. Opposites, they're going to cancel out. So I don't have any a terms in my final answer because they canceled out. So all I'm left with is this final answer of 3a cubed plus 5a squared plus 4. And so that's just what I'm left with. And that's perfectly okay. It's all right. Not every term in these problems has to have not every term has to have, or not every variable has to have a term in these problems. That's what I'm trying to say. So something like this is perfectly okay, where we go from a third power to a second power. We skip a term and we end up with, missing a term, but that's fine. Okay, so that brings us to the end of section 5.3/4. So as always, go ahead and start working on the video check for this section. Go ahead and try out these new skills for yourself. And in our next section, we're going to talk about the last operation, which is dividing polynomials. So until then, I will see you in the next video.